up here? All right, so we're good to go. Okay, so we're into the second week of class, and this week we'll really be focusing in on getting started with both Java and Android. So that's kind of our focus. So today we're going to do some introductory kind of Java stuff. If we have time, we'll get through lesson 1.0 today. If we don't get lesson 1.0 today, I'll do that tomorrow. So we've got some wiggle room in the schedule for today or tomorrow. Okay. So first things first, though, I do have a quiz regarding the PWA stuff that we covered last week. So that's the first thing I'm going to do here. I'll give you about 30 minutes to go ahead and take it. It's through Inside Rankin, and then we'll go and start with the Java material. So if you would go to Inside Rankin and find that assignment. Huh?
PWA quiz?
Yes, that is the one. PWA quiz. I'm going to pull up a link here. Oh, I did not get that assignment created. I need to do that. Coursework. Let me do this here. Okay, yes. So you're going to find it under one Progressive Web Apps. It's the PWA quiz, which is the second item here. So go ahead and take that, and we'll actually start the lecture at 30 minutes from now, so that'd be 12 or 1:10. Okay. So what I'm going to do is this is a guy that I watch for a lot of things, and he's got some really good and helpful lectures, and he's done a really good job of putting together something here in terms of beginner level Java, right? So that's actually where I'm going to start today, is watching through this. We'll pause this as people have questions and take breaks and talk about and discuss things. So, if you have any questions, just raise your hands. I'll pause it and I'll get to you, and we can kind of talk through some of those things that are in the video. Cool. All right. So that's kind of the plan for today, as we'll watch through that. This will probably end up being most of today, but whatever time we have left, we'll talk about then how do we use Java to build Android applications. So let me get this up and running. I'm going to try and get my audio on. And
hi, my name is Mosh, and I'm going to be your instructor in this Java course. In this course, you're going to learn everything you need to get started programming in Java. We'll start off by installing all the necessary tools to build Java applications. Then you're going to learn about the basics of Java. You will learn how Java code gets executed. You will learn how to build simple algorithms. And throughout this course, I'm going to share with you lots of tips and shortcuts from my years of experience. I'll teach you how to write good code like a professional developer. So by the end of watching this course, you will have a solid foundation in Java and be ready to learn about advanced Java features. I've designed this course for anyone who wants to learn Java. If you're a beginner, don't worry. I'll make Java super simple and hold your hands through this entire course. You're not too old or too young, you will write your first Java program in minutes. My name is Mosh. I'm a software engineer with 2 decades of experience, and I've taught over 3 million people how to code and how to become professional software engineers. I have a coding school at codewithmosh.com, where you can find plenty of courses that help you take your coding skills to the next level. I hope you'll stick around and learn this beautiful and powerful programming language. And now a word from this video's sponsor. As someone who runs an online business, I cannot stress enough the importance of staying safe online, which is why I was so excited when Dashlane reached out to me. If you don't know, Dashlane is the password manager and VPN recommended by Apple and Google, and it's a fantastic safeguard for keeping your information secure. It's completely free to use for your first device, so head over to dashlane.com/mosh to give it a go. If you want to upgrade to the premium to get VPN or dark web monitoring, you can use the promo code MOSH to get 10% off. Sign up for Dashline today and keep yourself safe online. Now, back to the course. In this Java tutorial, we're going to download and install the necessary tools to build.
Okay, troubleshooting audio just on the streaming side. 1 second. All I need to do is switch this over to change windows, screen, go live. All right.
Java applications. So open up your browser and search for JDK download. JDK is short for Java Development Kit, and it's basically a software development environment for building Java applications. It has a compiler, it has a bunch of code that we can reuse, it has a Java runtime environment, and a bunch of other stuff. So over here, you can see this page on oracle.com, Java SE, which is short for Java Standard Edition. Click on this. Now over here, click on this icon. Now on this page, you can see Java Development Kit for various platforms like Linux, macOS, and Windows. Here I'm on a Mac, so I'm going to download this DMG file over here. Now before we do this, first we need to accept the license agreement. All right, now let's download the DMG. When we open this, we're going to see this package. Let's double click this. And here we see this installation wizard. It's super easy. Just click continue and install. You have to enter your computer's password. And then, all right, done.
This is the
Beautiful.
part that we've already done.
So we can move this to trash. Now, the next piece of software we need is a code editor. There are so many code editors for building Java applications. The popular ones are NetBeans, Eclipse, and IntelliJ. In this Java course, I'm going to use IntelliJ, but if you have a favorite editor, feel free.
And so Android Studio that we're using is based off of IntelliJ. So a lot of stuff you'll see does apply directly to Android Studio because we're kind of using IntelliJ under the hood, right? IntelliJ and Android Studio are very, very similar. NetBeans and Eclipse. Eclipse is kind of the old dog in the race. It's been there around for forever in terms of building Java development. I think that it's where my dad, who does programming development in Java, that's where he started. It's an IDE that personally I have used. I personally don't care for much. I think if you're going to do Java development, you shouldn't pick Eclipse, suffice it to say. It's been around, it's been long-standing, but there's a reason that there are other IDEs out there that other companies are using. There's a lot of bad design decisions that Eclipse made. And basically around the idea that they wanted to build a system that was so generic that you could really write any language, not just Java. But the kind of paradigms that they've picked don't really fit well with how we think about graphical interfaces or IDEs, and there's some issues with how it builds the code too. So it's not something I would recommend. In fact, it doesn't work for modern Android development at all because it doesn't support a feature called Gradle. So Gradle is a really critical part of what we'll do this semester, but Eclipse doesn't support that. NetBeans is a much broader thing. It's actually been over 10 years since I've used NetBeans. But from what I remember from NetBeans, back then it was my favorite IDE to actually do Java and Python, etc. Development with. But there's a lot of other things that have come along since then. So those are all things you can still do Java development with, but you really, when you're building Android apps, you're locked into Android Studio, which is based off of IntelliJ. There really aren't any other good options out there, suffice to say.
Well, I was just going to say, at SAE, we used BlueJ. That's just like a very basic, like, Java IDE. Like,
Yeah.
Really not a whole lot of features, but I think it's just to get you up and running.
Yeah. I mean, my first introduction to Java was just using command line. Like, if you just know Java C and Java, those two commands can get you there with just a text editor. But that doesn't really scale as your applications get bigger and you want to build larger things, including Android applications. So there are a lot of options out there, even not using IDE, but most people prefer to have one, right? So yeah, so that's where we stand. So the stuff you see around the stuff you see around IntelliJ will be pretty close to what we're doing.
To use that to take this course. That's perfectly fine. So let's search for IntelliJ download. All right, you can see download IntelliJ IDEA. Click on this link. Over here, download the community edition, which is absolutely free, and it's more than enough for this course. So download. All right, now let's drag and drop this onto the applications folder. Beautiful. All right, we've installed all the necessary tools to build Java applications. So next, we're going to look at the anatomy of a Java program. In this Java tutorial, we're going to look at the anatomy of Java programs. The smallest building block in Java programs are functions. A function is a block of code that performs a task. As a metaphor, think of the buttons on the remote control of your TV. Each button performs a task. Functions in programming languages are exactly the same. For example, we can have a function for sending emails to people. We can have a function for converting someone's weight in pounds to kilograms. We can have a function for validating users' input and so on. Now let's see how we can code a function in Java. We start by specifying the return type of that function. Some functions return a value like a number, a date time, and so on. Other functions don't return anything. So the return type of these functions is void. Void is a reserved keyword in Java, and that's why I've coded that in blue here. Now, after the return type, we have the name of our function. So here we should give our function a proper descriptive name, like send email. This name clearly identifies the purpose of this function, okay? Now, after the name, we have a pair of parentheses, and inside this parentheses, we add the parameters for this function. We use these parameters to pass values to our function. For example, our send email function should have parameters like who is the receiver, what is the subject of this email, what is the content of this email, and so on. Now, in this tutorial, we're not going to worry about parameters. We'll look at them in the future. Now, after the parentheses, we add a pair of curly braces, and inside these braces, we write the actual Java code. Now, one thing I want you to pay attention to here is that in Java, we put the left brace on the same line where we define our function. In other programming languages like C#, it's more conventional to put the left brace on a new line, but we don't do that in Java. So we put the left brace on the same line where we define our function. Now, every Java program should have at least one function.
So the whole thing about braces, just so we're clear, isn't a requirement. It's not something you have to do. You can actually do it both ways. You can do it both ways in C#, you can do it both ways in Java, you can do it both ways in JavaScript. It's really just a stylistic convention. It originates actually from the all of the core original Java examples did it this way. And all of the original, like if you pull down Visual Studio out of the box and don't change any of the settings, it does it the other way. But if you change the settings on Visual Studio, then everybody does it the same way. So it's one of those things that people get in a tizzy. It's a matter of formatting. It's a matter of being consistent. It's a matter of set the setting in the IDE and have everybody on the team have the same setting. You remember we talked about that at the hackathon. It's when you have formatting settings like that, you need to make sure that everybody agrees and everybody's got the same setting in their IDE. Once that's good, then go for whichever approach you want. The hard part is getting everybody to have the same setting in their IDE. That's like the step one. And that historically has been a problem. VS Code makes it a little bit easier in the sense that you have a standardized place where you can put those settings that are shared across everybody on the team. But IntelliJ has not been particularly great at sharing settings between developers, just so we're clear. So that is one thing that we want to, you want to change. And if you're working with a team, you really need to make sure everybody's got the same formatting settings. Usually that means creating a configuration file, but that's not done out of the box. Cool. So if you decide you want to change your formatting, if you decide you want to move the curly braces down, just look into the formatting options and make the change. Cool. So it's not something you're locked into.
And that function is called main. So main is the entry point to our programs. Whenever we execute a Java program, the main function gets called and the code inside this function gets executed. Okay? Now, these functions don't exist on their own. They should always belong to a class. So a class is a container for one or more related functions. Basically, we use these classes to organize our code, just like how products are organized in a supermarket. In a supermarket, we have various sections like vegetables, fruits, cleaning products, and so on. Each section contains related products. By the same token, a class in Java contains related functions. Now, every Java program should have at least one class that contains the main function. Can you guess the name of that class? It's main. So this is how we define a class in Java. We start with the class keyword, then we give our class a proper descriptive name, and then we add a pair of curly braces. Now the functions that we define in between these curly braces belong to this class. And more accurately, we refer to them as methods. So a method is a function that is part of a class. In some programming languages like Python, we can have a function that exists outside of a class. So we call it a function. But when a function belongs to a class, we refer to it as a method of that class. Okay? Now, in Java, all these classes and methods should have an access modifier. An access modifier is a special keyword that determines if other classes and methods in this program can access these classes and methods. We have various access modifiers like public, private, and so on. Now, most of the time we use the public access modifier, so we put that in front of our class and method declarations. So this is the basic structure of a Java program. At a minimum, we have a main class, and inside this main class, we have the main method. Now, you might be curious why we have a capital M in the name of this class. Because in Java, we use different conventions for naming our classes and our methods. To name our classes, we use the Pascal naming convention, and that basically means the first letter of every word should be uppercase. In contrast, to name our methods, we use the Camel naming convention, and that means the first letter of every word should be uppercase except the first word. So that is why we have a capital M in the name of this class. All right, now that you understand the anatomy of a Java program, let's create a new Java project and see all these building blocks in action. In this Java tutorial, you're going to learn how to write and execute your first Java program. So let's open IntelliJ IDEA. Here on the home screen, let's create a new project. All right, on the left side, select Java and make sure Project SDK is not blank. So earlier we downloaded JDK or Java Development Kit version 12. That is why JDK version 12 is selected here. If you don't see that, make sure to select it from this drop-down list. All right, now let's click on Next. On this page, select Create Project from Template. So we're going to create a command line application, which is an application that we can run from the command line. It doesn't have a graphical user interface or a GUI. Now, I know a command line application is not as exciting as an application with a graphical user interface like a mobile app or a desktop app, but trust me, building an application with a graphical user interface is very complicated. So for now, we're just going to build command line applications to learn Java properly. Once you learn Java properly, then you can learn about building desktop or mobile applications with Java. All right, now let's click on Next. On this page, we have to give our project a name. Let's call it Hello World. Now over here, you can see the location of this project. So it's inside the IDEA projects folder. Now right below that, you can see the base package, which is set to com.codewithmosh on my machine. On your machine, it's probably going to be com.package. What is this? Well, earlier we talked about classes and methods. I told you that a class is a container for related methods. So we use classes to organize our code. By the same token, we have a concept called package, and we use a package to group related classes. So as our applications grow, we're going to end up with hundreds or even thousands of classes. So we should properly organize these classes into packages. Now, by convention, the base package for a Java project is the domain name of your company in reverse. So my website is codewithmosh.com. That is why I'm going to set the base package for this project to com.codewithmosh. Now, it doesn't mean that you should have an actual domain registered on the internet. This is just a way to create a namespace for our classes. So now every class that we create in this project will belong to this package. We're going to talk about packages in more detail in the future. So for now, just type a base package for your project. It can become .your name or whatever. It doesn't really matter. All right, now let's go forward. All right, here's our first Java project. Now, this code editor might look a little bit intimidating at first, but trust me, it's really easy, and you're going to learn about it throughout this course. On the left side, we have the project panel where we can see all the folders and files in our project. For example, on the top, we have the Hello World project. Inside this project, we have the source folder where we have the source code of our project. Now, in this folder, we have another folder that is com.code with Mosh. That is the name of our base package. And in this package, we have this class, main. So you can see this main file opened on the right side here. Now look at the name of this file. It's main.java. So all Java files should have the Java extension, okay? Now, let's collapse the project panel by clicking on this icon. That is better. So see what we have here. On top of this file, we have the package statement, and this is used to specify what package this class belongs to. So the main class that we have here belongs to this package. Now this package statement is terminated by semicolon. So in Java, wherever we have a statement, we should terminate that statement with a semicolon. This is exactly like C# or C++. Now below this package statement, we have our main class, exactly like what you saw in the previous tutorial. So we have public class main with a pair of curly braces. Inside this class, we have our main method. So it's a public method, which means it's accessible from other parts of this program. It's static. We haven't talked about static methods yet. We'll talk about them in the future. For now, just remember that the main method in your program should always be static. The return type of this method is void, which means this method is not going to return a value. And here in parentheses, we have one parameter for this function. We can use these parameters to pass values to our program. Again, we'll look at this in the future. Now, right after this parenthesis, you can see the left brace, and this is where we write the code in this method. Now, by default, we have this line prefixed with 2 slashes. This indicates a comment. We use these comments to explain our code to other people, so these comments don't get executed. Now, let's remove this comment and write a bit of code to print something on the terminal. So here we're going to use the system class in Java. So capital S, system. Here in this tooltip, you can see the system class is defined in this package, java.lang or language. Also, look at this icon on the left side. This indicates a class. Now, inside this class, we have various members. We can use the dot operator to see the members defined in the system class. Now, the member that we're going to access is out. Look at the icon of this member. It's F, which is short for field. We're going to talk about fields in the future when we talk about classes and object-oriented programming. Now, what is interesting here is the type of this field, and you can see that on the right side. That is print stream. So print stream is another class that is defined in Java. So once again, we use the dot operator to look at the methods or members defined in the print stream class. The method we're going to use is println, which is short for line. Look at the icon for this method. So M indicates a method. Now, you press enter, and IntelliJ automatically adds these parentheses as well as a semicolon. So now with the code on line 6, we're calling or executing the println method. Earlier I told you that inside this parenthesis, we can pass values to our methods. Here we want to print the hello world message on the terminal. So let's type double quotes, and inside these quotes write hello world. So hello world is textual data. In Java, whenever we deal with textual data, we should always surround them with double quotes. Now we say we have a string. So a string is a sequence of characters. All right, so we're done with our first program. Now to execute this, we can click on this icon on the toolbar. Look at the shortcut. On Mac, it's Control and R. I always prefer to use shortcuts because they're faster. So Control and R. Now, IntelliJ is building our application, and we can see the result in this little terminal window. So here's our hello world message. So that was our first Java program. Next, I'm going to explain how Java code gets executed under the hood. Hey,
So you kind of saw your first kind of intro to what the Java structure is and what that shell looks like if you're doing command line apps. Don't worry too much about that shell because obviously we're building Android apps. So how we start and invoke the program is quite a bit different in the Android world. So we don't have things like there's arguments that go in there for the string arguments you get on the command line. We don't obviously have that. Um, but other than that, there are definitely some similarities. So, for instance, when our applications always start up, we will have what we call a main activity. So the main activity is where your user starts. You can kind of think of it as the home page. But that's effectively the runtime and where your code is going to start into. Cool. Okay. But you're seeing hopefully that the syntax is very similar to C#. It's almost identical in all ways.
Mosh here. I just wanted to let you know that you really don't have to memorize anything in this course. I've put together a comprehensive cheat sheet with summary notes that you can download below this video. So I've done my best to create the best possible Java course, and I would really appreciate it if you support me by liking and sharing this video on the social networks that you use often. Also, be sure to subscribe and enable the notifications, so next time I upload a video, you'll get notified. Thank you so much, and let's continue watching. All right, now let's see what exactly happens under the hood the moment we run a Java program in IntelliJ. There are basically two steps involved here: compilation and execution. In the compilation step, IntelliJ uses the Java compiler to compile our code into a different format called Java bytecode. This Java compiler comes with the Java development kit that we downloaded at the beginning of the course. Let me show you. So here we can right-click on this main.java, and in this context menu, we have an item called Open in Terminal. It's down below. Unfortunately, it's not visible in my recording window. It's called Open in Terminal on Mac and probably Open in Command Prompt on Windows. So let's open that. We get this terminal window or Command Prompt on Windows. Here we're currently inside of this folder, Code with Mosh. That is where we have our main.java file. Now we can invoke the Java compiler like this, javac, and pass the name of our Java file as an argument. So main.java. If you're on Mac or Linux, make sure to spell this with a capital M because these operating systems are case sensitive. So enter. Now let's look at the content of this folder. On Mac or Linux, we can type ls. On Windows, we type dir. So let's take a look. In this folder now we have a new file, main.class. This is the bytecode representation of this Java file. Now, when we use IntelliJ to run our Java program, this class file gets stored somewhere else. Let me show you. So back to the project panel. Here in our project, we have this source folder where we have our source code, and we have this out folder where we have the result of the compilation. So inside this folder, we have production. Inside this, we have hello world, the same name as our project. Inside hello world, we have com, which is the name of our top level package. Inside this package, we have a sub package that is code with Mosh. And here we have our main.class file. So this was the compilation step. Now, this Java bytecode that we have in this file is platform independent. And that means it can run on Windows, Mac, Linux, or any operating systems that has a Java runtime environment. If we go to java.com/download, we can download Java, or more accurately, Java runtime environment for various operating systems. This Java runtime environment has a software component called Java Virtual Machine, or JVM. This JVM takes our Java bytecode and translates it to the native code for the underlying operating system. So if you're on a Windows machine, this Java Virtual Machine converts our Java bytecode into the native code that Windows can understand. This architecture is the reason why Java applications are portable or platform independent. We can write a Java program on a Windows machine and execute it on Linux, Mac, or any other operating systems that have a Java runtime environment. C# and Python also have the same architecture. That's why they're platform independent as well. Now let me show you how to invoke this Java virtual machine to run a Java program. So back to this terminal window, let me expand this. Currently we are inside of this folder, code with Mosh, and in this folder we have this class file. Now let's go one level up. So cd ... and one more time. So now we are inside the source folder. We can invoke Java virtual machine like this. We type Java, and then we type the full path to our main class file. What do I mean by that? Well, earlier we defined this package com.codewithmosh, and this class, the main class, is part of this package. So the full path to this class is com.codewithmosh.main. Make sure to use a capital M here because this is case sensitive. Now when we press enter, Java will look at this folder, com. Inside this folder, it will look at this other folder, code with Mosh, and then it will find main.class in that folder. It will load the bytecode and convert it to the native code for the operating system we are using. So take a look. So it executed our program, hello world. Beautiful. When we run a program using IntelliJ, all these steps are hidden from us. We don't see the compilation or execution steps. So you have seen Java in action. Now let me tell you 5 interesting facts about Java. Java was developed by James Gosling in 1995 at Sun Microsystems, which was later acquired by Oracle in 2010. It was originally called Oak after an oak tree that stood outside Gosling's office. Later it was renamed to Green and was finally renamed to Java, inspired by Java Coffee. That's why its logo looks like this. We have 4 editions of Java for building different kinds of applications. We have Java Standard Edition. This is the core Java platform, which is what we're using in this course. It contains all of the libraries that every Java developer must learn. We have Java Enterprise Edition, which is used for building very large scale and distributed systems. It's built on top of Java Standard Edition and provides additional libraries for building fault-tolerant, distributed, multi-tier software.
So it's worth mentioning any web development you do with Java will be with Java. Java EE is exclusively that's the web development space now. Is that the only case where that exists? Version Standard Edition traditionally was the version used on desktop. The closest one that Android is to this, Android is none of these 4, but the closest one it is to is Java SE. So Android includes most of the stuff from Java SE, not all of it, but none of the stuff from the other 3 is so worth it. So if you're looking at this and you're thinking Android development, your closest cousin is Standard Edition.
So, for instance, if you're building a backend in Java, you're using the Enterprise Edition.
You will be using an Enterprise Edition for sure, because all of the technologies people use for web development don't exist in Standard Edition. They're all based off of the Enterprise Edition. So things like servlets and JSP. Micro Edition used to be the version that was used on mobile devices. That was prior to Android. So prior to Android, there were some devices, some flip phones and whatnot in the 90s that did support Android, early 2000s. But those are basically mostly gone away. There are a few still around, but mostly they've gone away. So all of our mobile development is with Android rather than with Micro Edition. Yep. Michael, you had a hand? Okay, just stretching. And Java Card we won't talk about. That's actually literally to run Java on smart cards. Like think cards that are, the little chips you have on your like your credit card, right? Those smart chips might be running Java, but historically it was designed for actually SIM cards that you put in your phone. So Java Card is actually writing code that goes on SIM cards. Very few people have access to touch that code, suffice to say, and very few companies in the world have access to that.
I remember back in we're talking a while ago. Was Java ever used for front end stuff or a front end application on the web?
That would have been SE. Yeah. So if you're doing any front end, it used to be that back in the days of Flash, right? You actually had really 2 options: Flash or Java. JavaScript was not really an option yet. But you could build what we call Java applets, which were little Java applications that would run inside of the web page, kind of like a little widget, right? And you could make them work different ways. You could make games with them. You could do whatever you wanted with them. Large in part, their support was never as good as Flash's. So they didn't really see much light of day, and current web browsers don't support them at all. Like, support for them has dropped off completely officially just a year or two ago. So, yep. To answer that question. So yeah, initially it was applets, and that was under Java Standard Edition. So that's, if you're looking anything up, everything you're interested in for this semester is Java SE. In terms of if you're looking to get a professional Java development gig, and you see a position labeled Java developer, they're looking for these people. Just so we're clear. If an employer is looking for a Java developer, he's looking for somebody. They're looking for somebody that's Java EE focused and web development focused. Large in part. They don't always say that. Cool. Questions? Does that help kind of disambiguate a few things on that side? I think microaddition sometimes is still used in embedded systems. So there's still things like DVRs and Blu-ray players and TVs that are occasionally running Java ME, but those you'll kind of notice usually when you see them.
We have Java Micro Edition, which is a subset of Java Standard Edition designed for mobile devices. So it has libraries specific to mobile devices. And finally, we have Java Card, which is used in smart cards. The latest version of Java is Java Standard Edition 12, which was released just a few months ago in March 2019. Java has close to 9 million developers worldwide. Currently, about 3 billion mobile phones run Java, as well as 120 million TV sets and every Blu-ray player. According to Indeed.com, the average salary of a Java developer is just over $100,000 per year in the US. So as you can see, Java is everywhere, which means more opportunities for you to get hired as a professional programmer. Now, let me give you a quick overview of how I've structured this course so you can get the most out of it. This course is the first part of my complete 4-part Java series. Each part is about 3 to 4 hours long, so you can easily complete it in a day or two. In the first part, which is what you're watching, you're going to learn the fundamentals of programming with Java. In the next section, you'll learn about the type system in Java. You will learn how to work with various types, such as numbers, strings, booleans, and arrays. By the end of this section, you will build a mortgage calculator as your first Java project. We'll be improving this calculator bit by bit throughout this course. Next, you will learn about control flow statements that are used to build algorithms. We'll be talking about various types of conditional statements and loops. Later in this section, we'll add data validation to our mortgage calculator to force the user to enter valid values. At this point, you'll be able to build basic algorithms, and that's great. But being a good programmer requires knowing how to write good code that is clean and expressive. That's what separates an outstanding programmer from an average programmer. So in the following section, we'll talk about clean coding. I will show you various techniques that professional programmers use to make their code clean and maintainable. And finally, in the last section, you will learn how to find and fix errors in your Java programs, as well as how to package them for deployment so others can use them. So the materials in the first part will give you a solid foundation on how to start programming in Java. In the second part, we'll talk about object-oriented programming, which is a style of programming used in most, if not all, Java applications. Whether you want to use Java to build web, mobile, or desktop applications, you need to understand object-oriented programming well, because otherwise you're going to constantly hit obstacles. In the third part, we're going to talk about core Java APIs, or application programming interfaces. You'll learn about many of the useful classes in the standard Java library. And finally, in the last part, we'll be looking at the advanced features in Java, such as streams, threads, database programming, and so on. So I hope you're going to join me on this journey and master Java, the most popular programming language behind millions of apps and websites. In this section, we're going to look at the fundamentals of programming in Java. You're going to learn about variables and constants, primitive and reference types. You're going to learn about casting or type conversion. You will learn how to work with numbers, strings, and arrays, and how to read input from the user. Once you learn all this, I'm going to give you a project. You're going to build a mortgage calculator on your own. So make sure to pay great attention to all the materials you're going to learn because you're going to use most of them in this project. Are you ready? Now let's jump in and get started. In this tutorial, we're going to talk about variables in Java. We use variables to temporarily store data in computer's memory. Here's an example. Imagine in this program, you want to store someone's age in the memory. So we declare a variable like this, int age equals 30. So int or integer is the type of this variable. So in this variable, we can only store integers, which are whole numbers, like 1, 2, 3, 4, numbers that don't have a decimal point. Now in Java, we have several different types. I'm going to talk about them in the next tutorial. So first, we specify the type of our variable. Then we give it a name or a label. This is also called an identifier because we use it to identify our variable. This equal sign is called the assignment operator, and 30 is the initial value that we are assigning to this variable. So we say on line 6, we're initializing this variable, which means we're giving it an initial value. We always have to initialize our variables before reading them. So with this line, we're storing number 30 somewhere in computer's memory, and we're assigning this label to that memory location. Now on line 7, instead of printing hello world, we can print the value of the age variable. Take a look. So I'm going to run this program using Control and R. There you go. Now we see 30 on the terminal. Beautiful. We can also change the value of our variable. So after we initialize it, perhaps we can change it to 35. Now when we run this program again, we see 35. Beautiful. We can also initialize multiple variables on the same line, but this is something that I don't recommend because it makes your code ugly and hard to read. Here is an example. We can declare another variable like temperature and set it to 20. So using a comma, we can declare multiple variables on the same line. Now, even though this is technically possible, it's not something that I recommend. So it's always better to declare one variable on each line like this.
So I have one specific reason why I recommend against doing that in every language that allows it. And it really comes down to the fact that when you're working on code, you're rarely working on it by yourself. It's very rare that you're working on code by yourself as the only developer. If you define two variables at the same line, yes, there are some cases where that can make the code cleaner. It will always cause problems, though, when you're working with multiple developers. The reason being is your version control that we're using. So we're using like get, right? And get's not the only one that works this way. The way that it tells whether or not a line has been changed is by the line, right? So if you make any change on a line, the entire line is changed, which means if you've got 5 variables all on that line, any developer needs to do anything to those 5 variables, they may quickly be in conflict with another person who changed that line as well. So if you keep things at 1 variable per line, you will have a lot less conflicts to deal with. You'll have a lot less merge issues if you don't do that, right? It's just always asking for merge issues once you start down that road of allowing that. Cool? That makes sense? So it's really not a stylistic issue. It's just a matter of like, hey, code like that doesn't merge well, right? Code with multiple variables declared on the same line does not merge well, so we try to declare them on separate lines.
We can also copy the value of one variable into another. Here is an example. Let me delete these variables and declare a new variable called my age. We set it to 30. And then we declare another variable like her age, and we set it to my age. So now, when we print her age, we're going to see 30. Take a look. So on line 7, we're copying the value of this variable into this other variable. Now, one thing I want you to pay attention to here is the convention I have used for naming our variables. As I told you before, this is called the camel case notation. So we should capitalize the first letter of every word except the first word. So in this case, the first word, my, it's all in lowercase, but the second word starts with a capital letter. So this is all about declaring and initializing variables. In the next tutorial, we're going to talk about various types in Java. In this tutorial, we're going to talk about various types in Java. Basically, we have two categories of types. We have primitive types for storing simple values, and non-primitive types or reference types for storing complex objects. So in the category of primitive types, we have byte, which takes 1 byte of memory, and in 1 byte, we can store values from 128 to 127. Now, the more bytes we have, the larger numbers we can store. So next we have short, which takes 2 bytes, and with this we can store values up to 32,000. Next we have integer, which we have seen before. Integers take 4 bytes of memory and allow us to store values up to 2 billion. Then we have long, which takes 8 bytes, and with this we can store even larger numbers. Now all these types are for storing whole numbers that don't have a decimal point. If you want to store a number that has a decimal point, you have to use float or double. Float takes.
So just a few things to note there. Okay. So there's a few different sizes of integers that we can use, like namely byte, short, and long. Typically speaking, it's safe for most things in this course to just go ahead and use it. For most things in the course, it's just safe to go ahead and use it, except for anytime you're working with time. If you're working for time, definitely already you need to step up to a long. Any of the APIs that work with even saying, hey, it's so many milliseconds later I want to fire something, will require you to pass that as a long rather than an integer. Just a heads up there. So we will be using the longs. They'll come up. But those are going to be the two focus. You also might notice here that all of these types, notice none of them start at 0, right? All of them support negatives. So there are only signed types in Java, period. It does not support unsigned types, which is a really, really important thing. Java does not support unsigned types. Okay, that's contrary to languages that came before it. So like if you look immediately before it, it's based off of C++. C++ is both unsigned and signed types. In fact, your hardware, your processors that you're actually running your code on, all of those processors support both signed and unsigned types. Like it's there and it's a hardware feature that every CPU supports. So why does Java not allow you to use unsigned types? Any thoughts?
Because it runs in JRE.
Huh?
Because it runs in a JRE.
Well, why couldn't the JRE be set up to support unsigned types? It could be. They've just defined the machine that can't work with unsigned types. But why? Is there a reason for that? How many unsigned types have you used so far in this curriculum? Probably 0, right? Probably 0. So from an introductory programmer perspective, unsigned types are very rare, right? As an introductory, as a new developer, you tend to run into unsigned types not very often, okay? Mind you, they're always there, and they're used for something very important, namely that anytime you have a pointer or a reference, if you have an object that you're holding, that is an unsigned number, and it needs to be an unsigned number, which means that the first number that gets allocated is 0. 0 stands for null, and then everything there from 1 on, those get used to refer to objects in memory. Does that make sense? So they do exist there. Every runtime has them. They just may not be exposed to you because they may only be used for pointers, and you may not actually have access to that number. Okay, so the reason that they took that approach is you have to understand that there's kind of two motivations that come out of when Java was created and really based off of C++. So one of those motivations you've kind of heard already is this idea of write once, run everywhere. You write the code once, and then you can run it on every platform, on every CPU, and it just kind of magically works as long as there's a runtime, Java runtime taking care of all the details of all the differences, right, between those different platforms, whether it be Mac and Linux and Windows, etc., or between an ARM chip and an x86 chip and this x64 chip. It's dealing with all those details. So that's one reason why a lot of these differences exist, is the ability to run it everywhere. That's not the driving factor here, right? Because it is supported, unsigned numbers are supported everywhere. The other factor was trying to make it easier to write code, trying to make it easier to write and maintain code. And that's where this one falls, right? This one falls into one of those cases where most of the time you don't need unsigned numbers. So let's ditch it and make the code easier. You know, most of the times your signed numbers will work as a stopgap. You usually can go ahead and change the code over to use signed numbers when an unsigned number, when you would otherwise be using an unsigned number. Most of the time, that's not always the case. There are cases where you're going to run into unsigned numbers. One of the big places that I ran into them personally first with Java was that I was interfacing with another application. I was interfacing with another application that was written in C and C++ and was using and sending unsigned numbers across the network. So I was receiving those from that server, right? And so those kind of things can happen and can be a little bit of a struggle to work through, but it's been done, right? So just kind of keep that in mind, is that Java doesn't have unsigned numbers, right, as you're working with things. But I think the main reason that they got removed is largely it caused a lot of confusion over in the C++ world, right? And obviously I think the most confusing part with working with unsigns is that transition between, if I've got an unsigned number here and an assigned number here, if I want to go back and forth between them, that gets weird, right? So if I take an unsigned number, that could most of the time go over and be converted to a signed number, but not all the time. So for instance, notice that the range on the integer is negative 2 billion to 2 billion. The range on a signed integer would have been 0 to 4 billion. So anything that's over, it's not exactly 2 billion, but anything that's in that 2 to 4 billion range doesn't convert properly. You can't convert it from an unsigned number to a signed number. There's a whole extra 2 billion numbers that can't be converted.
So if you think of unsigned numbers like absolute values, kind of like,
to some sense, maybe, but that requires a lot more conversion and is not as obvious as it may seem. In fact, a lot of times it may not be possible, simply from the purpose that the way we represent signed numbers uses something called 2's complement. And so it becomes difficult to do that 2's complement, to go from a signed number into an unsigned number to a signed number. So oftentimes that means if you're pulling data from another system that is using unsigned numbers, you often may have to take that and put it into a 64-bit number when it was coming in as a 32-bit to make way for that extra range. That's one thing you may sometimes have to do. The other thing that occurs is, let's say you're going the other direction, right? I'm taking a signed number to an unsigned number. As long as it's positive, no issue. If I take a signed number into a unsigned number, there is no way to really do that. I can't represent the negative number over there in the unsigned world. So what actually ends up happening effectively is that negative number, if you do that without caution, it gets pulled over as a very large number, well, a very large positive number with almost no correlation to the negative number you started with. Similar the other way, you pull over a number that's too big from positive, from unsigned land over to signed land, it becomes a large negative number potentially, or a small negative number, whatever it may be. But you get that transition. So that can be all sorts of headaches. It's always caused problems in C++ when people do that. It's generally not safe, which is why we usually try to do those conversions in the first place. Like, you have to typically do an explicit cast to say, I want to convert this from signed to unsigned. Like, I know what I'm doing. I just care about the bits behind it. That's the only time you do that. If you care about the bits behind it and you don't actually care about the number, which is a weird case, right? But oftentimes it's the case when you're dealing with unsigned numbers. Usually when you're dealing with unsigned numbers, you only care about the bits. You don't actually care about the number. Cool. So things you got to watch out for, it's not something we are going to run into this semester, but if it's something you wanted to go further on in Java, you're going to eventually someday run into it. Hey, I've got this unsigned number, I need to do something with it. But cool. So just my 2 cents there.
4 bytes, double takes 8 bytes. So obviously with double, we can store larger numbers. Next, we have char for storing a single character like A, B, C. And these char types take 2 bytes, so they support international letters. And finally, we have Boolean for storing Boolean values, which can be true or false, just like yes or no in English.
Okay, so another 2 notes on types. So floats and doubles are exactly what you're familiar with. They're signed types. This one's got 32 bits. This one got 64 bits. So they can hold more things. Just on a back of the back of the envelope calculation, so you kind of know roughly how much space they can hold. You may remember from science class that there's this idea of significant figures. Roughly speaking, a float can hold about 5 significant figures at best. Okay, versus a double is about double that, so about 10 significant figures. So if you're trying to do calculations where you only care about maybe the first 2 or 3 significant figures, then floats are fine. As soon as you get out of that range and you need to do things that are more accurate, then you often find yourself doing doubles. In fact, games have gotten sophisticated enough that usually you need doubles for a lot of calculations in games. It used to be primarily that we were safe and we took the performance hit to do the performance benefit to do floats in most games, but we've really a lot of games have switched over to doubles because of the need for precision, especially open world games and other sorts of things like that. Characters are kind of weird. Okay, so the character in JavaScript in Java is 16 bits in size, or 2 bytes. It's a UTF. It represents a single UTF-16 character. Okay. Now, if you know anything about UTF in Unicode, how big are Unicode characters actually per the standard? So you remember how big a single UTF, what we call code point, is. Okay. So if you're looking them up in the documentation, every UTF-8 character today typically is a 32-bit character. Okay, so 32-bit character actually is how Unicode works. There's actually not enough space in 16 bits to fit all of the characters that we have. And there was a time where we thought, well, maybe we can fit it in 24, and that was something that actually affected the MySQL database. But today it's really 32. So you need 32 bits to capture any individual character. Okay, so there are some really common characters that cause issues with this. All of your emojis are 32 bits. Okay, none of your emojis fit in 16 bits. So just a heads up there. All of your emojis fit in 32 bits. JavaScript suffers from the same problem because JavaScript takes the assumption that a single character is 16 bits and not 32. So you have to deal with this in a lot of languages. Even C# made the same mistake. So it's not necessarily a mistake per se as much as it is, hey, things have evolved and we're using a lot more characters that didn't exist when those languages were created. So that's just a heads up. Right, so emojis work differently, work weirdly, because we have a lot of these languages that are using UTF-16 to store characters. It's also interesting because I remember prior to Java, the dominant languages really were C and C++. Their character types are 1 byte. In C and C#, C++, the character types are 1 byte. They're 8 bits. So Java and most modern languages have taken the other approach that they're 16 bits, but older languages were 8. Okay, so that's a little bit of context. Okay, so what that means is all of the characters actually that you see largely on your screen. Remember what character set that most Americans use? You remember the name of that? Starts with an A? ASCII, right? So ASCII covers the entire English alphabet, okay? It covers everything that's on your keyboard, okay? The ASCII alphabet only contains 127 characters. Only contains 127 characters, which means that all of ASCII only takes up 1 byte per character, just so we're clear. It only takes up 1 byte. So the way that works with Unicode is that we say, okay, well, we've got a 16-bit character. We'll make all the top 9 bits 0. And then the bottom 7 are actually ASCII character. So are you tracking with me there? Okay. So that's actually what happens with all of the characters that we send around. All of our ASCIIs are 9 zeros and then 7 actual bits that we care about for the letter. Okay. Versus if you're sending an emoji, you actually send one character that's half of one 16-bit unit that's half of the character, and another 16 that's the other half of the character. And so to get the whole character, you actually have to put both of those characters together, which is weird. So one of the things that I stress there, because of those kind of things, just recognize that a car is not a character. That's a common misconception. It's really just no different than a 16-bit number for all intents and purposes. It may be half of the character, maybe it may be the whole character. You don't know without looking at the data. Cool. That's one of those things that really it still trips me up. It trips up a lot of new developers in terms of working with ASCII and working with Unicode in those different formats, whether you're working with UTF-8 or UTF-16 versus UTF-32, things get really interesting. But that's just a definite thing to watch. So if you're working with things and assuming that those characters represent a single character, it will work as long as you're working on your own computer. It will stop working as soon as you get another language in. Does that make sense? Or you get emojis in it. That's where most people start seeing the pain. Okay.
Now let's take a look at a few examples. Earlier we used an integer for storing someone's age, but as you learned, integers take 4 bytes and allow us to store values up to 2 billion. We don't need 4 bytes of memory to store someone's age. All we need is 1 byte, because with 1 byte we can store values up to 127. So I'm going to change this to byte. That is better. Now let's look at another example. Let's say we want to store the number of times a YouTube video has been watched. So we define an integer called views count. Note that I'm always using meaningful names for my variables because these names help us understand what this code does. I've seen some people use variable names like v or v1 or n. Nobody knows what these variables do. So as a best practice, always use meaningful and descriptive names for your variables. So views count, we set this to a large number like 1, 2, 3, 4, 5, 6, 7, 8, 9. Now in Java, whenever.
So one thing just might mention here, he's talking about views count. That reminds me. Okay. Remember that views, this integer can go up to 2 billion, right? Are there any videos on YouTube that have more views than 200 than 2 billion?
Probably.
Does anybody know what video broke YouTube? Actually, it was. It was Gangnam Style. So they fortunately were using unsigned numbers, so it was 4 billion instead of 2 billion. But actually, Gangnam Style was the first one to hit 4 billion views. Believe it or not, it was. So they actually have to use 64-bit numbers to store views on YouTube now because of Gangnam Style. So. Always plan for the future is what I can say from that. Is what you think might fit into a 32-bit number, you will be astounded at how easy in computers it is to reach 2 billion. It's almost impossible to reach the limit of a 64-bit number. I haven't heard any cases of that happening yet. But there have been many cases where people have hit the limit of a 32-bit integer. Just so you know. Cool. I've also seen a game that I was working with and playing with, and their IDs had gotten so big that they were negative numbers in unsigned space. They had more than 2 billion registered player accounts. So they had negative accounts when you registered a new user.
Whenever you deal with a
Negative
large
IDs.
number like this, you can use an underscore to separate every 3 digits. Just like how we use a comma in our documents to make our numbers more readable, we can use an underscore in Java. So with integers, we can store values up to 2 billion. But let's say the number of times this video has been watched is 3 billion. So I added 3 here. Now we have a red underline that indicates an error. When we hover our mouse over it, we see this tooltip, integer number too large. So we need to change the type of this variable to long. However, the error is still there. What's going on here? The reason we're getting this error is that by default, Java sees these numbers as integers. So even though we have defined the type of this variable as long, Java compiler sees this value as an integer, and it thinks this value is too large for an integer. To solve this problem, we need to add an L as a suffix to this number. We can use an uppercase or a lowercase l. But as you can see, a lowercase l kind of looks like a 1, so it's better to use a capital L. So these are examples of whole numbers. Now let's declare a variable for storing a number with a decimal point. So double price, we set this to 10.99. Obviously, the double variable is too large for storing the price of a product. So we can change this to float. That is better. But we have a compilation error here. Take a look. Incompatible types, required float, but found double. The reason we're seeing this error is that by default, Java sees these numbers with a decimal point as double. So even though we set the type of this variable to float, Java sees this number as a double. So just like how we added a suffix to this number to represent it as a long, we need to add a suffix here to represent this number as a float. And that suffix is f. Once again, we can use an uppercase or lowercase f. So these are examples of numbers. Now, let's store a character. So char, we call it letter, and we set it to A. Note that we should always surround single characters with single quotes and multiple characters or strings with double quotes, okay? So char represents only one character, string represents a series of characters. And finally, let's see an example of a Boolean. So we define a Boolean variable called isEligible. Is this person eligible for loan or not? We set this to true or false. These are the Boolean values. Now, note that all these words coded in orange are reserved keywords in Java, just like public, static, void, class, package. These are all reserved keywords. So we cannot use these reserved keywords to name our variables, classes, and methods. In the last tutorial, you learned that we use primitive types to store simple values like numbers, Boolean values, or single characters. In contrast, we use reference types to store complex objects like data objects or mail messages. These are complex objects. Now in Java, we have 8 primitive types that you have seen before. All the other types are reference types. Let me show you an example. So here in this program, first I'm going to declare a primitive type. Let's say byte age equals 30. Now, declaring and initializing a reference type is slightly different from a primitive type. Let me show you. So let's type date. Now here in this tooltip box, which is called IntelliSense, we can see various classes that have date in their name. So IntelliJ is helping us complete our code by suggesting these class names. Now here we have a date class in this package, java.util. So this package contains a lot of utility classes that are useful in a lot of programs. We also have a date class in a different package, java.sql or SQL, which is used for programming databases. So this is the benefit of packages. We can have the same class, but in different packages. They don't conflict. So packages create a namespace for our classes, okay? Now, in this case, if we select the first date class and press enter or tab, IntelliJ automatically adds this line for us. Import java.util.date. So because currently we are in this package, in order to use a class from a different package, we need to import it. So here we're importing the date class in this package. We'll talk about packages in more detail in the future. So back to our date variable. Let's give this variable a name, like now. Now we set this. Here we need to use the new operator to allocate memory for this variable. And this is one of the differences between the primitive and reference types. When declaring primitive types, we don't need to allocate memory. Memory is allocated and released by Java runtime environment. But when dealing with reference types, we should always allocate memory. Now we don't have to release this memory. Java runtime environment will automatically take care of that. So we use the new operator and then repeat the name of our class, in this case date, and then we add parentheses, followed by a semicolon. In this example, this variable we have defined here is an instance of the date class. So these classes define templates or blueprints for creating new objects, new instances. As another example, we can have a class called human, and we can have objects like John, Bob, Mary, and so on. So an object is an instance of a class. Now, these objects or these classes have members that we can access using the dot operator. So we can type now dot, and these are all the members defined in this class or in this object. For example, we have a method called getTime, and this returns the time component of this object. This is another difference between primitive types and reference types. These primitive types don't have members. So if you type age dot, we don't see anything. These items you see here are not members of age. They're code snippets which allow us to quickly generate code. For example, we can select for I, and this automatically generates this block of code for us. We'll talk about this in the future. So this age variable is a primitive type. It's not an object. It doesn't have any members. And that's why when we use the dot operator, we don't see anything here. Now let's delete this line and instead print the value of this data object. So once again, we can type system. This is a class, so we can use the dot operator to access its members. Here we have out, which is a field, and the type of this field is print string, which is another class in Java. So once again, we can use the dot operator and call the print line function. Now let me show you a very cool shortcut. Instead of typing all this, we can use one of these code snippets. So we type SOUT and press tab, and this generates this piece of code for us. All right, now let's pass our data object here. Note that I have not surrounded this variable with double quotes because this is a string. And if we run this program, we'll see now on the terminal. There you go. We don't want this. We want the value of our data object, not a label. So let's remove the quotes and run the program again. So here's the current date time on my machine. Yeah, I've learned a little bit about the differences between the primitive and reference types. So you know that we use primitive types for storing simple values and reference types for storing complex objects. But there is a very important difference between these two categories of types in terms of memory management. And that's what we're going to talk about in this tutorial. So I'm going to declare a primitive variable, x, and set it to 1. And then I'm going to declare another variable like y and set it to x. So in this example, we have two different variables, x and y, and these two variables are at different memory locations. So they're completely independent of each other. In other words, if I change the value of x, y is not going to get affected. Let me show you. So I'm going to update x to 2 and then print y. So SOUT tab y. Let's take a look. So run. As you can see, y is not affected because x and y are completely independent of each other. However, when we use a reference type, this behavior is different. Let's take a look. So I'm going to delete all the code here. In Java, we have a point class that is defined in this package, java.awt. So we press enter, and now we have this import statement on the top. Beautiful. Let's declare a variable like point1 and set it to new point. Here we can pass the initial values for x and y. So I'm going to pass 1 and 1. So IntelliJ automatically adds these labels, x and y. Now, just like before, I'm going to declare another variable, point2, and set it to point1. And this is where things get interesting. When Java runtime environment executes line 8, first it's going to allocate some memory to store this point object. Let's say the address of that memory location is 100. Then it's going to allocate a separate part of the memory, and it's going to attach this label to that memory location, point1. In that memory location, it's going to store the address of our point object. So this is the critical difference between primitive and reference types. When we declare a primitive variable like a byte, the value that we assign to that variable will be stored in that memory location. But when we use a reference type like this point class, our variable is going to hold the address of that point object in memory, not the actual point object. Now look at line 9. Here we're copying the value that we have in this variable into this other variable. So that value, as you learn, is not the point object, is the address or the reference to the point object in memory. That is why we refer to these types as reference types, because they don't store the actual values, they store a reference to an object somewhere in the memory. So in this example, point1 and point2 are referencing the exact same point object in memory. We only have one point object. So these two variables are not independent of each other. They're referencing the same object. And that means if I update this point object through either of these variables, the changes will be visible to the other variable. Let me show you. So using the first variable, point1, we're going to update the value of x. So we use the dot operator, and here we can see the members of this object. X and y are both fields, which are variables that exist inside of a class. So we set x just like a regular variable to a different value. Let's say 2. Now, because point1 and point2 are referencing the exact same object, if we print point2, we're going to see the change that we just made. Take a look. So SOUT tab, let's print point2. Run the program. There you go. So the change was visible. So remember this. Reference types are copied by their references, whereas primitive types are copied by their value. And these values are completely independent of each other. In this tutorial, we're going to look at strings in Java. So earlier in the course, we printed the hello world message on the terminal. This hello world that we have here is a string, or more accurately, it's a string literal. That means a string value. Now let's extract this from here and store it in a string variable. So cut. Just before this line, we type string. Now look, this string class is defined in java.lang package. What is interesting is that we don't have an import statement to import this package or import this class because this package is automatically imported. So we can use any classes that are defined in this package. Now let's declare a variable called message. And because this is a reference type, we should instantiate this variable using the new operator. So new string, and here in parentheses, we type our message, hello world. However, here we have this little warning. Take a look. New string is redundant because in Java, there is a shorter way to initialize string variables. Let me show you. So instead of using the new operator, we simply set this to our string literal. Now on the surface, this looks like a primitive type because we are not using the new operator, but this is just a shorthand to initialize a string variable. Strings are reference types in Java, but because we use them often, there is a short way to create them. So now let's pass message to the println method and run our program. We get the exact same result as before. Beautiful. Now let's look at a few interesting things that you can do with strings. We can concatenate or join a string with another one using the plus operator. So here we can combine this with another string with 2 exclamation marks. And here's the result. Now, because string is a class, it has members that we can access using the dot operator. So we can type message dot, and these are all the methods or functions defined in the string class. For example, we have this method here, ends with, and with this, we can check to see if our string ends with a character or sequence of characters. For example, here we can pass a string to see if our message ends with 2 exclamation marks. Now, instead of printing the message, let's print this expression here. So let's run the program. We get true. So this method that we have called here returns a Boolean value, which can be true or false. We also have another method, starts with. Let's take a look. Now in this case, we get false because our message doesn't start with 2 exclamation marks. Another useful method is length. So we can call that to get the length of a string, which is the number of characters. So message.length, take a look. So in this string, we have 13 characters. And this is useful in situations where you want to check the length of the input by the user. For example, you might have a sign-up form with a username field. You can check the length of someone's username and give them an error if the username is longer than, let's say, 20 characters. Pretty useful. We also have another method that is index of, and this returns the index of the first occurrence of the character or the string that we pass here. For example, if we pass h, the index of h is 0. So let's run the program. There you go, we get 0. If we pass e, we get 1 because the index of the first e in this message is 1. Now, what if we pass a character or a string that doesn't exist in this message? Let's say sky. We get -1. So with this method, we can check to see if a string contains certain characters or words or sentences and so on. Another useful method is replace. And with this, we can replace one or more characters with something else. For example, we can replace any exclamation marks with, let's say, a star. So this replace method has 2 parameters. One is target, the other is replacement. And here we're passing 2 values for these parameters. Here's the first value, here's the second value, and we have separated these values using a comma. Now in programming terms, we refer to these values as arguments. A lot of programmers don't know the difference between parameters and arguments. Parameters are the holes that we define in our methods. Arguments are the actual values that we pass to these methods. So in this case, target and replacement are parameters, but exclamation mark and asterisk are arguments. Now let's run this program and see what happens. So our exclamation marks are replaced with stars. Now what is important here is that this method does not modify our original string. It returns a new string. So if we print our original string right after SRUT, tab, message, you can see the original string is not changed because in Java, strings are immutable. We cannot mutate them. We cannot change them. So any methods that modify a string will always return a new string object. Okay? We also have another useful method to lowercase. Let's take a look. So to lowercase converts all characters to lowercase. And once again, you can see that the original string is not affected because this method returns a new string. Okay. We also have to uppercase. And another useful method is trim. Trim. And with this, we can get rid of extra white spaces that can be at the beginning or the end of a string. Sometimes our users type unnecessary spaces in form fields. So using the trim method, we can get rid of these white spaces. Let me show you. So I'm going to add a couple of spaces before and after our message. Now, when we trim it, these white spaces are going to get removed. Take a look. So here's the original string. You can see 2 white spaces at the beginning, and here's our string after trimming. So these are some useful methods in the string class, but this class has more methods that we don't have time to cover in this lecture. But as we go through the course, you're going to learn more about the string class and other useful classes in Java. There are times we want to include special characters in our strings, like a tab or a new line, or a backslash or double quotes. So in this tutorial, I'm going to show you how to include these special characters in your strings. So here we have the string, hello Mosh. Let's say we want to surround Mosh with double quotes. Now here's the problem. If we add a double quote here, Java compiler thinks this is the termination of our string, so it doesn't understand what we have after. That's why we have a compilation error. To fix this problem, we need to prefix this double quote with a backslash. So using this backslash, we have escaped the double quote. Now, one more time, let's add backslash double quote here. Now let's run the program and see what we get. So we get hello Mosh in double quotes. Beautiful. So double quote is one of those special characters that you need to be aware of. Another special character is backslash. Let's say we want to store the path to a directory on a Windows machine. So that will look like this. C drive, backslash, Windows, backslash, whatever. Now, if you want to store this in a string, we need to escape each backslash. Let me show you. So C drive, backslash. Now we have a problem. Java compiler thinks we're escaping the double quote here, so it thinks our string is not terminated with another double quote. But that's not what we want. You want to add a backslash here. So we need to prefix our backslash with another backslash. Now we type Windows, one more time, something. Let's run the program. So even though we have 2 backslashes in our code, we actually see 1 backslash in the terminal window. Another escape sequence is \n, and we use that to add a new line to our strings. So let's change this to \n and run the program to see what happens. Now our string is broken down onto multiple lines. On the first line, we have C drive, then we have Windows. So wherever we add a \n, Java will insert a new line. We can also add a tab in our strings. So if we add \t here, there will be a tab between C drive and Windows. Let's take a look. So C drive, here we have a tab, and then Windows. Now in Java, we have a few more escape sequences, but quite honestly, they're hardly used. So remember these 4 escape sequences that we covered in this tutorial.
So it's worth mentioning that issue with paths and having to put 2 slashes there is actually a really big issue. It is as cumbersome as it looks, and it does cause a lot of problems. It's enough that certain other programming languages have actually changed how they work at an operating system level, where like the way that things work on Linux and Mac is they use forward slashes instead of backslashes, and then you don't have that problem, right? Outside of that, the other things that have happened is most other languages have said, oh, this is a problem. We need to do something about this at a language level. So C#, just a few years ago, added a special syntax to C#. Microsoft added a special syntax to C#. Actually, I should do this on the screen so everybody can see it. Where's my notepad? So in Java, and this has also been a problem in C++ too. So this would have been string path is equal to, and let me run this in language J Java, so we get the syntax highlighting. And so this would have been like he did. Right. So we've had to do that for a long time in the Java and the C++ world. In the C# world, what got added just a few years ago was a different way to do this approach, which means that you put an @ sign at the beginning and ignores the slashes. So in the world of C#, you can do this today. You just put an @ sign in, and then you don't have to double up the slashes. It does mean that you can't use any escape characters in that string anymore, but that's usually okay for things like paths, right? For things like paths, and regular expressions also fall into this boat, where regular expressions use a lot of slashes, a lot of backslashes, and so having that behavior where you don't have to escape them is really helpful for regular expressions as well, not just paths. Cool. So it actually turns out there's multiple uses for that simple little syntax. Over in the JavaScript world, it's really easy. You already know how to do it. Over here, I would say const path is equal to, and I'd use those backticks. And as long as I'm using those backticks, actually I think, am I right about that? No, because the backticks still can contain slashes. So actually I take that back. I do think in JavaScript that we're still stuck with the former, realistically. You can use any kind of quote on there, but it doesn't really matter. It has the same effect, because I'm forgetting that you can still do sequences and template strings. Sorry. It's still a problem. It's still a problem in JavaScript. There's not really what we're going to do. Does that help a little bit for context? I'm hoping, I really, really hope that someday JavaScript takes a node from C# page and does the @ sign thing. And I hope that, honestly, that Java does the same. But they haven't yet. All right. This is probably a good time to take a quick break, quick breather, and stretch our legs. So let's go ahead and do that. We'll come back at 2:50 and we'll finish this part up.
How much time do we have left in the video?